Hey y'all, Data Guy here. And today I have a video for you where I want to just run through some of the top data streaming tools with an eye towards giving you a sense of, what each ones are good at, which ones are bad, which ones have, some cons, with the eye of helping you figure out, hey, what is the best data streaming tool for your particular use case? Because I think all of these could make the case for being a really good data streaming tool. But in the world of data streaming, there is quite a degree of variability in, what would actually be optimized for what you want to do. Do you need true streaming? Could you get away with really fast batch streaming? Do you have that technical skills to actually manage all the underlying compute, or do you need to manage service for it? So that's some of the things we're going to explore today. And the first thing we're going to talk about is Apache Kafka. Shocker, because this is probably the most popular data streaming tool. As you'll see, even another one of the tools on this list is just a managed version of Apache Kafka. But Kafka at its core is a distributed streaming platform that really allows for high throughput, fault tolerant streaming of data, where it's designed to handle data feeds in real time and is really widely used for building real time data streaming applications and pipelines. And it's able to do this because Kafka typically runs on large clusters of many different compute engines all strung together. As you can see, you can have these clusters stretch across multiple availability zones, multiple clusters. You can have many different clusters that are actually linked together. And this allows it to handle millions of messages per second. Obviously you have to run a whole lot of compute for it to be able to handle that, but it is possible with Kafka. And it's also really easily scalable, where you can scale, up to trillions of messages per day, keep adding elastically more compute when there's a lot of, messages going through your system, and then scale down and kill those compute engines when they're not needed. So you're not just paying for infrastructure you're not using. And it's really also designed to be very durable. It uses a distributed commit log, ensuring your data is safely stored, even if there's a failure in one of the nodes. That commit log is stored in a central repository. And it's also flexible enough to be able to connect to really anything and can support real-time data processing, but also batch processing. And with all of these kind of benefits, you also do have a couple of cons. Number one is just complexity. It is really difficult to manage if you're not very well versed in kind of the Kubernetes verse and managing open source products. And when you get to that scale of trillions of messages per day, you're going to be managing hundreds, if not thousands, of different compute engines. And so having systems in place that can actually handle that is really important. And kind of in tandem with that, it requires a lot of operational overhead, where you're going to have careful planning and systems for, hey, how are we going to deploy this compute? How are we going to monitor it? How are we going to maintain it over time? How are we going to, fix things and push updates? So there's a lot to think around running Apache Kafka, but it can be used for those really, really, large use cases where you need the ability to scale to, accommodate those millions, billions, trillions of messages in a single day. Now, our second data streaming tool is one I've explored a couple times on this channel, and that is Apache Flink. So Flink is a framework and distributed processing engine for stateful computations over bounded and unbounded data streams. So whether you need true streaming or you need bounded, where you're processing chunks of data at a time, Flink is designed for handling both real-time event processing, out of order events, and even batch jobs. Kind of a one-stop shop for whatever your data processing needs are. And you can see, SQL on stream and batch data. It provides a full API for interacting with this through the data stream API and data set API. And it's designed to really run in whatever setup you need it to. Any common cluster environment, you'll be able to run Flink, and it's able to perform computations at in-memory speed. So it's performing computations right there on disk really fast as the data is flowing through. So one data point comes in, Flink can process it, just that single point of data, and then bring it into that backend system. And this makes it really good for event time processing, where you want to process and change. Whereas Kafka, it's really good at handling, hey, ingesting this message. It doesn't necessarily perform any operations to alter the contents or process that message, or sorry, not process, but like change or alter that message while it receives it. And so Flink is able to actually do that processing right at the point of message generation, and is able to do those kind of stateful computations across many different streams. And it's also very scalable. It's designed to work on really any kind of compute engine, and is just generally very flexible. But with that flexibility and capability, again, comes a really steep learning curve. You have to know how to write Java files. It's quite difficult to get set up with actually building your own Flink workflows. It just requires a lot of understanding of specific to Flink terminology and tools. And it's also quite resource intensive. So for smaller data streaming needs, it's probably not going to be super useful, or not super, it will be useful, but it's going to be expensive if it's a smaller application for what you're getting out of it. So really designed for kind of enterprise grade, large scale use cases. Now, PachiStorm, our next data streaming tool on this, is kind of on the opposite end of the spectrum. It's a little bit older than Flink and Kafka, and is really meant to be, an easier introduction to reliably process unbounded streams of data. So doing for real-time processing, kind of the tagline is doing for real-time processing what Hadoop did for batch processing. It's very simple to use. If you go look at the product information here, it's just all about simplicity. So you have the ability to write transformations in PachiStorm in really any language. It provides fault tolerance on data processing. It's simple to set up and use for real-time data processing tasks. But because it's a little bit simpler to use, it doesn't have kind of the efficiencies that Flink and Kafka have. While it does say, PachiStorm is fast, it can probably process over 1 million tuples per second per node. It just isn't quite as efficient at doing that as a system like Flink or Kafka is. And also managing it at scale can be challenging. Just to get set up is pretty easy, but it's a little bit harder to scale with it just because kind of those previous reasons. It's just not really designed for super large scale. It's really designed for kind of smaller data processing needs, and we're just running a single cluster of a couple nodes and just listening to an event and doing some basic computation on the messages that are emitted by that application or object, whatever. Next, we have Amazon Kinesis. And so Amazon Kinesis, their really tagline is, hey, it's going to make it easy to collect, process, and analyze real-time streaming data. It is the classic, Amazon tool built really into the Amazon ecosystem, seamless integration with other AWS services, but probably not going to interact well with services that you're using outside of Amazon. Because it's an Amazon managed service, you don't have to worry about scaling it yourself. You don't have to worry about managing the underlying compute or having to worry about optimizing that. It's going to automatically scale to match the volume and throughput. And it's just really easy to get set up and get started with it. So, it's an Amazon managed service, right? So you just click spin up and you have the ability to run it. You don't have to do kind of the optimization or building out the cluster that's going to underpin it yourself like you would have to do with the Apache services. But you're going to pay for it. It's going to cost quite a lot of money, especially at scale, especially for really high throughput streams where you need a ton of compute assigned to a particular job, or you're handling just millions and millions and millions of tasks. So can get more expensive, and it's also a proprietary service. So customizing it, if you need to change some of the underlying characteristics of Kinesis, you're probably out of luck. Versus like Flink or Kafka, you have the ability to actually edit the underlying code. With Kinesis, you're pretty much locked into what Amazon gives you, which can be a good or a bad thing. If you don't have the experience of managing services yourself, Kinesis is probably a great option for you. Next on the list, we have kind of Google Cloud's version of a streaming service, which is Google PubSub. And PubSub, if you see kind of here where it sits in the messaging layer of ingesting data, it is a messaging service for exchanging event data among applications and services. And its key, characteristics are, hey, it's really durable message storage and real-time message delivery with high availability, consistent performance at scale, all using the underlying Google infrastructure that you don't have to manage. So it's really good for if you just need something to sit in the middle of your series of applications and move data between them as data is, generated and then consumed. And so really highly reliable and scalable. And also integrates well with kind of other Google Cloud services because it's a Google Cloud native service. It's going to have built-in connectors, things like that. And it's got a pretty straightforward API to use. You can see it's got a few different use cases, a lot of great features here. And obviously, easy to set up, for someone that doesn't know how to, manage compute clusters or set up all the processing engines yourself. But similar to Amazon Kinesis, it kind of poses those same vendor lock-in risks where if you're connecting to things outside of the Google ecosystem, it's going to be quite difficult. And then pricing can also be a concern because, as you get to larger and larger scale, it's not going to scale it's going to scale linearly in terms of the amount you're paying. So, once you get to the millions, billions message threshold, you might want to think about self-managing with a different service because it's just going to be really expensive to actually use PubSub for those kind of use cases because, Google has to make their cloud dollar somehow. Now, I had to do something for Azure since I did something for AWS and Google. And Azure's kind of streaming solution is Azure Streaming Analytics. So this is a streaming tool that is really designed around just processing data for analytics engines. So it's meant to just kind of sit at the start of wherever data is being produced and then, do some chain operations to just process data for use in downstream applications. It's really low code kind of setup. So you can see here, you can design it graphically, the diagram of, hey, I want to ingest data from these 3 nodes and then do some processing. And then I want to use that to power a dashboard. So you can see here, you have some pretty dashboards where it's a good tool for, hey, I just need to do real-time analytics. If you have like a live dashboard you want to use, maybe internally or externally, wherever, Azure Stream Analytics is probably a good solution for that because it just will give you that pretty easy to use low-code environment for, hey, I just want to, always update this dashboard with the most recent and relevant information, but I don't want to have to worry about managing all that underlying compute. I don't want to have to manage, really anything around the complexity of what's going on underneath the hood. I just want something that's going to update my data and just make it really easy to kind of maintain and, obviously be low code. So people that, might be data analysts, they're not going to typically know how to, manage compute clusters or something like Kafka or Flink. So this is kind of a good entry-level tool for streaming, but it's going to cost a lot. And with low code comes a lot of limitations, as anyone that's worked with low code tools can attest. So that is some of the downsides there, where you're not going to have all the flexibility that you might have with an open source tool. And that is kind of my general run through of the lay of the land of streaming products. You also have, it's worth mentioning is Confluent. So Confluent is basically a managed version of Apache Kafka. So this is where, if you, hey, I want the capabilities of Apache Kafka, but I want to have a more managed solution. I don't want to have to worry about maintaining all of the underlying infrastructure myself. I want it to be cloud native. That's where Confluent is probably a great solution for you, where you're kind of in the middle intersection of, hey, I want to have the really deep customizability and large scale that Kafka provides, but I don't want to have to manage all the underlying infrastructure, and I don't want to be locked into kind of a cloud proprietary product. Confluent is a great solution for those use cases, and it kind of comes along with all the same benefits of Kafka, but without the con of needing to actually manage it yourself. But then again, you're kind of replacing that with additional cost for, a managed service, which is the same as any kind of SaaS offering. But worth mentioning that it's kind of the trade-off there between, hey, pay more and make it easier to use, right? Which is, can either be good or bad for your company. So I hope I've given you good lay of the land, the data streaming ecosystem, and enough information to tell, hey, which one is right for your use case. So hope you enjoyed. Have a good one. Data Guy out.